Children, this is the last example of this chapter. Problem number 8 given on page number 23. But it is a combination of two examples. One is problem number 5, which we have already solved. And this second part, which begins from the word now, this is an extension to that problem number 5. So actually half of the problem is already solved. The remaining part is something new. Okay, so let us start with the solution. We are given that these two lines are parallel and these four rays QX, QY, RX, RY are the respective angle bisectors. We have to prove that quadrilateral QXRY is a rectangle. Let us start with the proof. Line AB is parallel to line CD. If these two lines are parallel, we know that alternate angles are congruent. So we have written CRQ is equal to RQB. CRQ is equal to RQB. So this angle is equal to this angle. This is what we have said. And we have given the reason also. So if these two angles are equal in measure, half of this angle is equal to half of this angle. Okay, both the angles are equal. So half of them will also be equal. So these two are equal. But what is the half of angle CRQ? CRQ is this complete angle. Its half will be this angle. That is angle XRQ. So we have written half of CRQ is equal to XRQ. In the same manner, half of this angle will be equal to this angle because this is the angle bisector. This is also the angle bisector. So we have written half of RQB. Half of this angle is this angle. That is angle RQY because these two are the angle bisectors. RX and QY. These are the angle bisectors of these two angles. Okay. So now these two sides will be replaced by their equivalent. So here you will write XRQ and here you will write RQY. So you get the equation. That equation 1 becomes XRQ is equal to RQY. XRQ is equal to RQY. These two angles are equal, but these are alternate angles, and when alternate angles are equal, the two lines are parallel. That means ray RX and ray QY are parallel. We have written ray RX and ray QY are parallel. This is what exactly we have done in problem number 5, that the two rays are parallel. Okay. So till here whatever I have written is actually the repetition of question number 5. Now if I have proven that RX and QY, they are parallel, in the same manner we can prove that QX and RY, that is the second pair of opposite sides, this pair, they are also parallel. So we have written similarly we can prove that QX, this ray, and RY, these two rays are parallel. So we have proven these two rays parallel, and similarly we have written that these two are also parallel. So if the opposite sides of the quadrilateral are parallel, it becomes a parallelogram. Therefore, from 2 and 3, from this equation and this equation, this quadrilateral is a parallelogram. I have given number 4 to that equation. Now, angle XRQ, that is this angle, XRY, this angle is the sum of these two angles. Okay, let me rub this. This angle plus this angle, I have written XRQ plus QRY. XRQ plus QRY. But what is XRQ? XRQ is half of this angle CRQ. We have already written XRQ is half of CRQ, but I have written again XRQ is half of CRQ. Similarly, this angle is half of angle QRD. So half of angle QRD. So in these two places, you can write their equivalents, and therefore equation 5 becomes XRQ is equal to half of CRQ plus half of QRD. Take half common. What do you get? CRQ plus QRD. But if you observe CRQ and QRD, they form a linear pair. Okay, and therefore the total is 180 degrees. We have written a reason linear pair. So here it will, if you write this here, you get half of 180 degrees. So So XRQ, the left hand side, is equal to half of 180 degrees, that is 90 degrees. So this angle is a 90-degree angle. In a parallelogram, if any one angle is a right angle, then that parallelogram becomes a rectangle. Okay, so this is a 90-degree angle and this is a parallelogram. So in a parallelogram, if one angle is a right angle, then that is a rectangle. So we say that quadrilateral QXRY is a rectangle, and it completes the proof of this particular problem as well as the whole chapter. Thank you, children.